Have you ever wondered how faulty information in AI training data can spread unseen? Hidden reputational debt in AI training data is a serious issue. Inaccuracies and biases embedded in datasets affect AI outputs. These distortions shape how entities are represented in AI systems over time. In this video, we explore how AI models inherit and propagate these inaccuracies. Large datasets undergo multiple transformations before influencing outputs in AI systems. Let's break down the technical architecture of AI training pipelines. First, we gather data from various sources, including web scraping, public databases, and user-generated content. This data is then cleaned, normalized, and filtered. If unverified data slips through, initial distortions are introduced, leading to potential reputational debt. Once the data is pre-processed, it is transformed into vector representations using embedding models. Here, relationships are encoded. However, biases present in the data distribution begin to distort the vector space geometry, making it difficult to isolate individual inaccuracies. Next, during model training, parameters are optimized to minimize prediction errors. This process can amplify prevailing narratives in the data while suppressing less frequent signals. Reputational debt embeds itself across countless parameters, becoming resistant to targeted correction. When the model generates output, it retrieves learned patterns. Distortions manifest subtly in language generation and how entities are described. This complexity challenges the detection and correction of biases embedded within the system. Feedback loops are another critical factor. AI-generated outputs are indexed and rescraped into new datasets. This recursive cycle compounds existing distortions, making it harder to trace original data sources. At the system level, several failure modes arise, including distributed bias encoding and temporal staleness. These issues can affect the accuracy and reliability of AI outputs. To mitigate hidden reputational debt, we must implement effective strategies. Improving data curation and validation helps ensure only high-quality data is processed. Continuous monitoring of data ingestion and training calculations can also reduce the persistence of reputational distortions. Ultimately, addressing hidden reputational debt is essential for building trustworthy AI systems. Implementing transparent data pipelines and traceable training processes will minimize long-term distortions affecting AI representations. Join us in improving AI integrity. Consider subscribing for more insights into AI training and mitigation strategies. Remember, informed AI deployment starts with understanding the architecture and ensuring accurate representations in our systems. As we delve deeper into the architecture of AI training pipelines, we must recognize the importance of robust data curation methods. Effective curation requires not just cleanliness, but also a critical eye to detect potential biases lurking in the shadows of training datasets. By implementing stringent validation techniques, we can create a more reliable framework for assessing the integrity of the data collected. This process involves cross-referencing data sources and leveraging community feedback to highlight inconsistencies. The next step involves transforming the cleaned and validated data into a format suitable for model training. Here, we employ embedding techniques to convert textual data into numerical representations, facilitating easier manipulation by the learning algorithms. However, this process is fraught with challenges, as biases inherent in the dataset can significantly impact how these embeddings represent real-world relationships. For instance, if certain groups are underrepresented or misrepresented, the resulting embeddings can reinforce stereotypes or inaccuracies, further complicating the AI's output. Regular audits of the embedding process are crucial to ensure that these vector representations remain accurate and fair, minimizing the risk of propagating reputational debt. After generating these embeddings, the model enters the training phase, where it begins to learn patterns and associations from the numerical data. During this stage, it's critical to monitor how these patterns evolve, as unseen biases can emerge and solidify into the learning algorithm. Adjustments may be necessary to counteract the weight given to these biases, ensuring that the model remains fair and representative of diverse realities. Additionally, examining the loss function used to optimize predictions plays a significant role, as it directly influences which patterns the model prioritizes. If metrics favor prevailing narratives within the data, the risk of amplifying existing biases skyrockets. Thus, an iterative approach to training isn't just beneficial, it's essential for creating equitable AI systems that can operate without distorting reality. As we progress through the training phase, the model's architecture plays a pivotal role in determining how effectively it learns from the numerical data. Each layer of the model processes the embeddings in distinct ways, gradually refining its understanding of the relationships present. Notably, attention mechanisms can prioritize specific features, but if the underlying data carries biases, those will be accentuated, potentially skewing the results. Thus, ensuring that the model's attention aligns with accurate representations is crucial. Throughout this journey, continuous evaluation of performance metrics serves as a check against inadvertently reinforcing reputational debt. By implementing regular feedback loops, we can adjust the model's parameters dynamically, ensuring it remains sensitive to the nuances and variations in the data, paving the way for more equitable AI outcomes. As we examine the subsequent phases of the AI training pipeline, we encounter the critical process of generating outputs. During this phase, the model applies its learned patterns to produce language or responses, inherently influenced by the biases ingrained throughout the previous stages. The outputs may subtly reflect skewed narratives or reinforce societal stereotypes, raising concerns about the integrity of what is presented. Consequently, it is essential to implement rigorous evaluation methods to identify and rectify these distortions before deployment. Addressing hidden reputational debt is a collective responsibility, requiring cooperation across the AI community. By prioritizing transparency and accountability, we can foster a culture of ethical AI development, ensuring that future advancements are built on a foundation of accurate representation and fairness. Together, we can reshape the landscape of AI for the better.